Okay, so we open the thermostat application, run thermostat in trial mode. Okay, close this window and then click plus at the thermostat explorer. So select project and then create a new project by right click and then new project. Search for where the location of the data store. Click Coastal Vulnerability folder and click OK. Okay, so the coastal vulnerability model evaluates the exposure of coastal community to storm-induced erosion and inundations. So the next is to evaluate the effect of the changes on coastal vulnerability and then to produce a population density map. So continue, click Ecosystem Service Modeler and then Coastal Vulnerability. Okay, and then for the land area image, click search for the MV underscore landmass. Click OK. Coastal line image, MV underscore coastal line, and then OK. Same for the study area image, click MV underscore AOI. Okay. And then the output file name as a MV underscore fetch FETCH run. Click run. Okay. Since coastal habitats play an important role in protecting coastline, scenario of habitat modification can also be performed to evaluate the effect of those changes on coastal vulnerability. For each coastline segment in this study area, vulnerability ranks from 7 environmental variables are combined to produce qualitative vulnerability index that represent the level of physical exposure of the coastal area. Geophysical characteristics as well as the erosion buffer capacity provided by natural habitat are included in the calculation. This model also produces a population density map to highlight the coastal community that are vulnerable to damage from storms. Okay, so the following of the inputs can be used to calculate vulnerability index. First is coastline geomorphology, and then elevation, coastal habitat. Number 4 is sea level rise. Number 5, wind exposure. Number 6 is wave exposure, and the 7th is surge potential. Wind and wave exposure are calculated from the fetch distance. The fetch distance threshold at 12500, and then the average depth is 500. Okay, so each of the optional input variable, except for the storm surge, is ranked on a linear scale from 1 to 5 in order of increasing vulnerability to erosion and inundation from storm. So, So while waiting for the file to process, we will explain about the rank for the vulnerability index. Mm, okay, so the first rank indicate very low, second is low, third is moderate, four is high, and then fifth is very high. So the fifth very high indicate the red color, and then the four high indicate um orange, and then for the moderate is yellow, and then the low category is green. Wind and wave exposure are important vulnerability variable, but it is difficult to calculate. The coastal vulnerability model uses a fetch procedure intercept to estimate the average wave power that winds can generate across a seascape. The fetch procedure breaks the study region into 16 quadrants and calculates the length of water over the which a given wind may blow to produce wave in each quadrant. A long patch often produces a high energy wave capable of causing erosion and inundations along the coastline. In the model, the user enters a patch length threshold that determines whether a coastal segment is considered exposed to wind and wave erosion. If the patch threshold is reached at the coast from two or more directions, the location is exposed, otherwise it is shelter. For each exposed segment, the model will predict the power of locally wind-generated wave and oceanic wave that reach the coastline. Okay, so after it done, let's move to vulnerability index. Okay, so the fetch output file should have automatically been filled with the file just created moments ago, named as mv underscore fetch. The average depth is at the default of 500. Next, um, open now specify the remaining mandatory inputs. Click the for DEM image, click select MV underscore elevation and then OK. For the population, select MV underscore population file and then click OK. So click for the shoreline geomorphological, anthropogenic structure, sea level rise, natural habitat, raster group file. So for the shoreline geomorphology, select file mv underscore geomorphology and click OK. For the anthropogenic structure is mv underscore coastal structure. For the sea level rise, Select file name mv underscore sea level rise. And then for the natural habitat raster group file, select mv underscore habitats. Then click OK. For the natural habitat table, browse the file for mv underscore natural habitats. Then click OK. For the outfit file prefix, name as mv underscore va. And then lastly, click run. Yes. At the end of this process, the coastal vulnerability model will produce two main index output, which name vulnerability index and erosion index. However, the last two are only produced if the optional variable required to compute them are included in the model. So for the vulnerability index, this is the final vulnerability index that combines both erosion and inundation. Area with a higher value indicate higher vulnerability. For the erosion index, the index is a relative value representing the vulnerability of coastal segment to erosion due to wind and waves. Okay, so for the another output, which named as inundation index, the output depicts a relative index value representing the vulnerability of coastal segment to inundation due to sea level rise and wave surge. Uh, the inundation index are not displayed because we don't choose the search potential box before. While waiting for the file to complete, so let me explain about the effect of the storm surge to the coastal line. Storm surge is a rise of a sea surface height that occurs offshore as a result of wind stress, and atmospheric pressure associated with storm activity. High winds pushing on the ocean surface causes the water to pile up, especially over shallow water, resulting in a wave break at the shore that can cause significant damage and loss of life. Storm surge is impacted by the slope and width of a continental shelf. Gentler slopes tend to produce large storm surge, while steep slopes limit wave pile-up. If there is a continental shelf within the region of interest, it may be important to include its location so that the distance between the shelf and each segment of coastline may be calculated. If not, it may be useful to extend your area of interest so that includes a portion of the closest continental shelf. In general, as the distance from shore to continental slope increase, the potential for storm surge is also increased. Okay, so next, a net change in sea level will also impact local erosion and inundation patterns, a fact that is causes for concern in a coastal communities worldwide. To include vulnerability due to sea level change, this model requires an image of the coastline where each pixel is assigned a rank value associated with sea level rise. In the table, the suggestions for rank assignment are provided for two scenarios: future sea level change, as to predict the value in feet or meter for some time in future, which may be calculated using the climate change adaptation modeler in dataset. And the second is current sea level change, is a rate of change in month over year, which may be obtained by interpolating between National Ocean Service data stations in the United States. For future sea level change, a relative rise between -1 month and over than 1 month does not significantly alter erosion and is therefore given a rank of 3. But a sea level rise greater than 1 month over than 1 month may increase vulnerability to flooding in some areas, which rank as 5. Likewise, a sea level decrease greater than lower 1 month may decrease vulnerability, which are ranked as 1. For current sea level change, a rate of 1.8 months per year represent the global eustatic sea level rise, and any rate above this level is representative of local isostatic or tectonic land motion. Therefore, a rate less than 1.8 millimeter per year is indicative of very Therefore, a rate less than 1.8 millimeter per year is indicative of a very low vulnerability coastline, but rates much more higher than 3.4 millimeter per year at said international standard and are therefore suggest of high vulnerability. Okay, so for the vulnerability index process is complete. This show the erosion index and vulnerability index. to click the zoom in and then click zoom to see what the result is. So we can see the yellow color, the red color, and also some of the green color. So the red color here indicate it is a vulnerability category is very high, and then for the yellow over here, it shows the moderate category. And then we also see zoom the orange color, which indicate high, lower than very high. And also we can see green color, which defined as low vulnerability. Move on to coastal vulnerability index. Okay, zoom. Okay, here we can see all of the color, which are green, yellow, orange, and red. So it is the same result as the erosion index. That's all from us. Thank you.